Hi, welcome to Pre-AP Physics 4.2, Momentum and Impulse. We're going to be solving problems today. Momentum. Momentum is inertia in motion or mass in motion, and that momentum carries the notion of both mass, which is inertia, and velocity, which is motion. So momentum is equal to mass times velocity. Momentum is in the same direction as the velocity, and it has to be. Momentum then is a vector because it has a direction associated with it. So for example, a 20 kilogram object moving at 10 meters per second has a momentum of 200 kilogram meters per second, mass times velocity. Something massive moving fast carries a lot of momentum. Something really massive moving not so fast carries a lot of momentum. And something with very little mass doesn't carry much momentum unless it's going really fast, like we saw in the video last class. So it is possible for things to have equivalent momenta. This bus has a mass of 9,000, a velocity of 16, has a momentum of 144,000 kilogram meters per second. Whereas this car is smaller than the bus, it has a mass of 1,800 kilograms, a velocity though of 80 meters per second, has the exact same momentum. That means it's going to be just as hard to stop as the bus. Finally, if you have a train is massive. A train has a mass of 36,000 kilograms and is only moving at 4 meters per second, has the same momentum as the other two. It's going to be just as hard to stop as the bus or the car. So let's talk about impulse. Given that we know momentum is mass times velocity, if the velocity changes, the momentum changes, and acceleration, either positive or negative, occurs. But we know the following. One, for acceleration to occur, a force has to be applied, right? And two, if a given force is applied over a long period of time, more acceleration occurs. Impulse is a measure of how much force is applied for how much time, and it's equal to the change in momentum. So impulse is force times time, or F times t. A force applied over time will change the momentum of an object. So we looked at this picture yesterday. If force times time is equal to mass times the change in momentum, impulse is equal to the change in momentum, right? And we talked about all the relationships, but notice force, F equals ma, but a is the change in velocity divided by time. So mass times the change in velocity divided by time is the force. So look at these two relationships. In the top relationship, you have a truck that has a mass and a velocity and hits a haystack. The haystack provides a long period of time so that you have a small force of impact. But if the same truck moving at that same velocity were to hit a wall, you would have a very small amount of time for that impact and have a force that was greater. Impulse momentum relationships. Remember, force times time is equal to mass times the change in velocity. Since time is directly related to velocity, when the force and mass are constant, the longer the cannonball is in the barrel, the greater the velocity. Rifles have such long barrels so that the velocity of the bullet coming out is greater. So impulse examples. Getting punched by slowly or getting punched fast. Follow through increases the time for the collision in hitting a baseball. A In football, the defensive player applies a force for a given amount of time to stop the momentum of the offensive player with the ball. And hitting a brick or hitting a stack of wood, karate chopping it, so to speak. Case 1, increasing the momentum, the bat and the ball. The impulse of the bat decelerates the ball and accelerates it in the opposite direction very quickly. Case 2, decreasing momentum. It takes an impulse to change momentum. Remember, impulse is force times time. If you want to stop something's motion, you can apply a lot of force over a short time, or you can apply a little force over a long time. Remember, things break if you apply a lot of force to them, like the truck. This is also why if you're having to jump from a building, they generally will put an airbag of some sort or a trampoline. It is so that the amount of time for your impact with the ground is lengthened. Decreasing momentum over a short time. If the boxer moves away from the punch, he extends the time and decreases the force while stopping the punch. But if he moves toward the punch, he decreases the amount of time and then increases the force. This is why airbags are so important. The airbag extends the time over which the impulse is exerted and decreases the amount of force. If you didn't have the airbag, you would hit that steering wheel or dashboard or whatever a whole lot faster and harder than if you have an airbag. Again, karate chop, hitting the bricks with a sharp karate blow very quickly maximizes the force exerted on the bricks and helps to break them. So here's an example of momentum. I've filled in the entire TÜV chart, but I've colored the boxes that came from the example in blue. So Jennifer has a mass, so that's my first term, mass, of 50 kilograms, that's my first unit, is riding at 35 meters per second, that's my second unit, in her red sports car when she must suddenly slam on the brakes to avoid hitting a deer crossing the road. She strikes the airbag that brings her body to a stop. Stop can actually be a term. Remember, because we had start and stop both being terms before. In 0.5 second. So what average force does the seatbelt exert on her? Well, filling in the rest of everything we know, meters per second is your velocity. M is 50, V naught is 35, V is 0, time is 0.5, and the force is what we don't know. So the equation we need is Ft is equal to M delta V. The time is 0.5, mass is 50, and the change in velocity is 35, to give a force of 3,500 newtons on her body. That's quite a bit. You'll be doing a lot of problems in class today on momentum and impulse. Thanks for watching.